So I already said my name 2 or 3 times, so you guys are all good on that. Anyway, I'm originally from Northeast Ohio. It's good to be back, actually. I live in Texas now. I've been there for a couple years. So today I'm going to talk to you guys about creating your own custom Linux distributions via package aliasing. How many of you guys have actually created your own packages in Linux before, RPMs or debs? Okay. And the rest of you interested in pen testing then, I'm assuming? Okay. So I'm also releasing a project today, PentestRepo.com. I just put it up about an hour ago live, so you guys can hit that later on if you want. My slides are also located there if you want to reference anything later on. So here's a quick overview of what I'm going to go over. Just so I don't lose anybody, I'm going to quickly go over a packaging primer. If you are familiar with packaging, this is a good review. How packages are actually pulled by remote repositories. And this will give you an idea of some of the techniques and patterns that I'm leveraging in order to customize distributions through a single package. And then at the end of this, I will go on about the PentestRepo project, which is now in alpha stage, and hopefully you guys enjoy it, and I can get some feedback from you guys. So first off, what is a package, right? It sounds like a silly question, but we have them in all operating systems. In Windows, we have something called an MSI, and you use it to install your applications. In Mac OS, we have DMGs. On your cellular phones, you guys have packages that you pull down from Android or the Apple Store, and they install into your iPhone. And in Linux, we have packages that we pull down, and they're typically debs and RPMs. And basically, what you can think of a package is it's a group of files needed to typically run an application. It's not always an application you're installing, but sometimes you're installing libraries. But it's a glob of files that you need in order to get the job done. So as I mentioned, in Linux, we typically have debs and RPMs. Debs are found on Debian-based systems, Ubuntu, etc. RPMs are found on Red Hat-based systems, CentOS, Fedora, SUSE, not really Red Hat-based, but they also use RPMs. Other distributions also use these packages, but these are the main ones for debs and RPMs. There's obviously other packages. Gen 2, we have eBuilds. BSD systems, we have Port. We have BitBake on embedded systems. So now, we have our packages, and we also have these applications in order to manage them, right? So we have package management applications. For deb packages, we have apt, and you'll find this also on Debian-based systems, and yum for RPM packages. And the way to think about a package management system is it helps you manage your packages, right? So you have this package. It will help you lay down the files contained within the package. It will help you pull them from remote repositories in order to install them on your system. It will keep track of what's installed so you can later on remove them. And so the easiest way to think about a package management system through apt and yum is it's really a simple structure, right? It's a client-server architecture where yum and apt act as the clients, and they pull from remote repositories. The remote repositories are, simply put, just web-hosted files. A simple directory structure is typically found. It's always a unified directory structure in order to maintain compatibility with the actual application accessing it. So here's a simple example, right? For apt and yum, we have these configuration files. For apt, they're typically in etc app sources, and yum, they're in etc repos.d. At the bottom is a sample snippet from a apt config file where it's a directive telling us, hey, pull deb binaries from example.com, this URL, look in the main directory structure, distro, and any subdirectories under that, main and testing, right? And as I mentioned earlier, your server that's hosting these packages it's simply put, just a web structure, right? It's just a web server hosting files in a unified directory structure. Typically, you'll see Apache being used as a backend for these. Nginx is another great web server for serving static files. Typically in testing, I just always run python-m, simple HTTP server, and this will create a simple web server in your current directory so you can access it. Okay, so at the top is a sample configuration that I showed in the previous slide. A little bit simpler, and it's corresponding directory structure on a remote server. So the client in their configuration file, they're going to look for binary packages from url.example.com in a directory distro and a subdirectory main, right? And in the bottom is the actual web server's directory structure and how they actually host these packages that you're pulling down. So you see var ww, which is the typical layout for an Apache system. You have a main directory distro. Within distro, you have a releases file, which is just a simple configuration file. We don't really need to get into it too much. I'm just trying to give you guys a simple overview. Underneath main, we're going to have our architectures that we're looking for. And then finally, our subdirectory, subdirectory main, then our architecture directory, and then that is where our actual packages are hosted. Another important thing to notice in this sample is packages is your index of all packages located within your subdirectories. Okay, and so how do we actually maintain this stuff? You can do it by hand, right? You can get in there, mkdir, make all your directories, make sure you don't make any typos, and everything should work. Create your package index files with tpkg scan packages, plop that in the correct directory, and you're good to go. There's also automated tools to help you out. RepRepo is a great one. It's typically what I use for remote repositories. DAC is another one. DebArchiver is another one. Through the rest of the speech, I'm mostly going to concentrate on debs, so I don't take twice as long in order to explain everything. As far as remote tools to help me automate RPM servers, I typically do those by hand. If anyone knows of a good RPM management system, talk to me afterwards. I'd like to hear about it. Okay. So on to the nitty-gritty, right? I was just trying to give you an overview of how packages are pulled and managed by your system. But inside of a package, we have these directory structures, right? We have like, So package internals, okay. I want to explain this stuff to you guys so you guys can actually understand what I leverage with inside of packages in order to expedite my process and get it done in a quicker way. So with inside of a package, a deb or an RPM, we basically have a tar structure, which is just a directory structure along with files inside of the directories. And during an install of a deb package or an RPM package, this directory structure is just overlaid on your base operating system. And this will actually lay down all the files for your install during a package install. During an install, you also have triggered scripts which are run pre laying down the files, post laying down the files, and before and after removing files. And on top of all of this, we have configuration files located within every package too. So an example would be a template file, a rules file. We can also put in other things like copyright files. But most importantly is the control file. Control files are for debs. In an RPM, you're going to see a spec file, which is kind of like a control file, just globbed with other config files that are separated within the deb architecture. So the control file is what I really leveraged in my project. It can be as simple as the following line, right? The mega simple example of a control file is just this 5-line file, right? We have 5 directive variables mentioned here. Package, the name of the package we're about to create. Version, the version number of the package we're going to create. The architecture for it, and depends, right? Depends, I want you guys to keep in your head. Like, just note it right now because this is one of the things that I actually really leveraged within packaging in order to get my project done as quick as I did. Then a description, right? You can write anything here. And this is about as simple as you can get. You could actually create a package with this. You're going to get a few errors because I took out everything else, but it's mostly just warnings, right? Everything will actually be created from this. Okay, so what are the dependencies that I mentioned in the last slide, right? So for every package in a deb or an RPM, we have dependencies, and basically they explain what your package depends on in order to run. So in the previous slide, I showed Python is my dependency. So when I install my package, it's going to install Python along with it, right? And our package management system, apt and yum, actually handle this stuff for us, so we don't need to worry about it later on. But if you think about it, we can actually use the dependencies to make a package which solely just installs other packages. And this is what I mean by leveraging dependencies. So here's a more complicated example. It's not very complicated, it's really simple actually. But a dependency example on how you can actually install multiple applications within just one package. So we have our control file again. You could actually take all this right here as I go through it and run it all on your computer right now, and you would have a package that would actually install these applications. But for our control file, open up your editor, Vim, whatever, create your package. We named it favorite packages here, version number 0, architecture all, and dependencies. I am actually listing multiple dependencies here. I'm saying IPython, Vim, and Screen, and I'm saying these are my favorite applications just because I use them all the time. And then we're going to create a directory structure in order to put this control file in. Right? So a typical Deb architecture is as follows, right? We have our favorite applications directory. We have a Debian subdirectory underneath that, and we put our control file in there. Now, if I go to the parent directory of favorite applications and run the following command, bang, I have a package, right? Now, if I took this package and installed it, it has no binaries, it has no configuration files that it's going to install your operating system, nothing. All it does is simply install other applications. So how many dependencies can you include, right? I haven't hit a limit. I've put in hundreds and hundreds and hundreds, and it seems that everything works fine, right? So what if, instead of my favorite applications being just a handful of applications, I picked a whole genre of applications to install for dependencies? Wouldn't this be really similar to, say, a remastered Linux distribution that basically comes with a lot of genre applications? In the end, there really is no difference. If I created one package that installed every single package in your Linux distribution that was respun by someone else, it's the same thing in the end. So what do we gain from using package aliasing as opposed to actually using remastered distributions? I think there's 3 main keys here. We gain flexibility, maintainability, and security. There's also some cons involved, but these are the benefits. So if I have time at the end, I'll go on about some of the cons of actually using this technique. So flexibility. Packages typically will be created this way, will be compatible across sister distributions, right? So if my favorite if my favorite Windows manager is KDE or something like that, I can install GNOME, take my package, my alias package that I created, and install it there. But if I'm Joe Schmo and I say XFCE is a lot better, I can install Xubuntu, take the same package, install it there, and everything works just the same. So we gain this flexibility of we can pick whatever window management sister distribution we want, take the same application and have it installed the same exact way across different distributions. These packages are typically compatible across similar distributions, right? So if I took an Ubuntu package I made and I tried to install it on Mint, which ends up using the same back-end remote repository, we're gonna end up getting the same thing accomplished, right? Because its remote repositories have all of the same names that we're aliasing. And sometimes they're compatible across distributions that just actually use the same package management system, right? A Deb repository is not going to be the same as an Ubuntu repository, but typically the packages within them are similar names. So depending on what you pick in order to install in your into your package using aliasing, you might get lucky and it could work. So along with this, we also get maintainability, right? And this is kind of a big thing as far as people who respin their own distributions and deploy them to people. When a new distribution comes out, they have to take that new distribution, install all their applications, make sure everything works, respin it, and then deploy that, right? Whereas with the package aliasing system, all you have to do is just take that same package, put it onto the other distribution, install it the same exact way, and typically it's going to work if you're going to a newer distribution because in the long run, packages typically don't disappear. They're just appended to, right? There's going to be more packages. Sometimes there will be renaming of packages, but this is really easy to find out, right? If you try to install this alias package, it's going to complain right on the command line. It's going to say, hey, this package doesn't exist. You go into your control file, change it, and you're good to go. And as long as you're pulling packages from core repositories, you're also going to gain the benefits of all of their updates, right? So if they have security updates in their distributions for their repositories, you're going to end up pulling the same thing too. And so onto security, which is a bigger thing, right? How much do you really trust the guy who spun your distribution? So typically there's a chain of trust, right? You trust, we'll take Ubuntu for example, you trust Ubuntu, you're going to install their operating system. You must trust them somewhat at least, right? And then if you're going to take on someone else's respun distribution, you're now trusting another guy in between. Did they have any malicious intents when they created it? Who knows, right? We don't really know. A great example of this was a speech done last year at DEF CON 19, Get Off My Cloud, where as a test of this, they took a Backtrack 5 CD and they made an EC2 AMI out of it. And within the AMI, they wanted to test how many people would just blindly install these AMIs, right? And he replaced some of the init scripts with remote home, just wget scripts or whatever. It would hit his web server, and he would know that someone installed his AMI, and it's running. And he actually put in the init script, hey, if you see this file, email me and let me know, right? He actually got no replies for it. Hundreds of people installed this, and no one really knew, right? It goes to show that not a lot of people actually examine the distributions that they're installing, that someone else respun. And so another benefit that we gain from package aliasing rather than a respun distribution is it's really easy to inspect, right? A simple command like ARX, right? It's going to pop open a deb file. You can look at exactly what your aliases are, if there's going to be anything else installed in your operating system, or if that's it. Whereas with a respun distribution, there are so many points that you need to check in order to assure that nothing has been done to it, right? It could be rootkits, it could be backdoors, someone could have put in an SSL, CA cert, so anytime you go on their networks, you can sniff your packets, and no one's going to know, and then you're not going to be able to tell. So also everyone makes mistakes, and we can't help it. Did the person who spun your distribution put maybe a public-private SSH key pair on it, deploy it to thousands of people? Now everyone has a private key in order to get into your box. Did maybe they enable a user that they shouldn't have, root, for example? And on top of that, did maybe they give him a super easy-to-use password? And this is going to be deployed to thousands of people. So anyone who actually gets this similar distribution knows stuff about your distribution. Other, simple errors, right? Did they forget to configure an application to not start during a default install? Open ports that shouldn't be just because they were setting it up and they wanted it to be simple for them. Another prime example is developers will disable security enhanced Linux settings, right? Did the person who spun your distribution do that and then forget to put it back in? So is this a new idea? Leveraging dependencies in order to get this job done. Yes and no, right? I've never seen it taken to this extreme where you install hundreds of applications in order to get what you want. You see it every day in remote repositories. Take, for example, if you just do like apt-get install Postgres, right? It's a simple alias that's going to install Postgres server and Postgres client for you. But in order to make it easy for you, they just have a package named Postgres. Typically, it's only meant for one or two packages. And also, RPMs actually have an API that allows you to take the same approach. It's called group install, right? I have a little rant about actually using this technique. Basically, what group install will do is on your remote repository, you define a comps XML file, and this comps XML file defines all the packages that this group will install. The problem I have with it is I do a lot of package management across packages, right? So I'll make debs, and I'll try and make an exact same similar RPM. So when I actually do the development for these things, I try to keep everything as generic as possible, right? So if I can leverage package aliasing the exact same way in a deb and an RPM, I would rather use that rather than in a comps XML, right? This goes for other nice things that they put for you in packaging systems. Debs, for example, they have template files, right? But RPMs have no concept of this, so I really try to avoid it. Same with debconf, right? debconf. If you're not familiar with it, it's a localized database for apt, which stores configurations about the application you're about to install. So the next time you install or you upgrade, it keeps the same configurations and it can put them in for you. These are the things I try to avoid and just try and be as generic as possible. So onto the nitty-gritty. I took this technique and I created my own repository for it, PentestRepo.com. Basically, it's a remote deb and RPM repository. It supplies a bunch of alias packages for debs or for yum and apt clients, and it provides applications, not a couple of applications that I've put in that are not in your actual core repository, right? I'm still a little slow on getting these in there. I was debating whether or not to even include my own packages and just keep everything as a core, core OS repositories, because that means then you need to trust me, right? If you're going to install my stuff, I could be putting bad things in my packages, and you're not actually taking all these things from Canonical or Red Hat or whatever. So where did I get my package list? Why are my package lists better than anyone else's? I don't know. They might not be, right? I went to sectools.org. I parsed through the 125, their top-ranked security tools, found which ones were open source and contained within core operating systems, included those. I went to other pen test distributions, namely Backtrack. I took all installed applications in a Backtrack, installed a very similar, just minimal, 10.4 install, did a diff against the two, figured out which ones in the diff were in your core distribution repository, and then included those into PentestRepo's packages. And I also put in some of my favorite applications too that are not included. So currently, I support 4 versions of Ubuntu, which may be more, right? You might be able to take the same package and install it on any other version you want. I also include 12.4 here, even though it hasn't really been released yet. It was in beta when I made the 12.4 one last week. So the 12.4 packages, I think they're missing like aircrack-ng and ettercap, which is weird. Other than that, everything else is there. Fedora 16, I meant to have it done by now. I just haven't gotten around to spinning my RPM and putting it up on my repository yet. So I supply 3 types of packages. I have an all package, which is kind of the mother load of all pen testing tools. I think it ends up being, I think it's over 300 packages aliased in the all install. I do a light version, which is probably about 30 to 50 pen testing applications that are most commonly used, or what I judge was most commonly used. And I also created like a command line interface version, right? Where, a lot of times I have a server out there, a headless server with no window manager installed, and I want a couple of pen testing tools, and I don't want to go through and manually apt-get install all of them. So I made a package where it's only going to install applications that have no GUI interface for them, like window management, a GTK GUI or a Qt GUI, and curses is okay. Installation is simple. You don't need to worry about writing this down. I have all the install steps on the website. But basically, it's as simple as this. Crack open your app source lists, add the one-liner there, deb, PentestRepo, whatever distribution you're actually installing to. For this one, I used Ubuntu, was that 11.10, right? I don't know. I always get the names and the numbers mixed up. And then alpha, right? I'm still in alpha stage, so all of my subdirectories are just alpha. Update your remote repository, sudo apt-get update, and then install it, right? I typically recommend installing PentestRepo Lite. You can go for whichever one you want. So what am I going to do in the future with this? I'd like to add more packages. I'd like to clean up a lot of the packages I currently have. I'm not going to lie, the diff between Backtrack and a clean system had a lot of packages that were semi-dependencies of other packages, right? So they don't really need to be there. They would get installed anyways. I ripped this out mega quick, so I had no PGP signatures on any of the packages. Super simple to add. It's probably, like 10 minutes for me to fix that. Support for more distributions, obviously. Like I mentioned, I've been using Fedora a lot more lately, so I'd like to get my Fedora RPM up. During an install of a large amount of applications, 300 with the all install, you're also going to get, they have template files installed in a lot of the debs that you're installing, so you're going to get pop-ups, right? I think currently you get about 5, menus that come up. What IP address would you like Snort to listen on, or you know what I mean? I wouldn't mind configuring sane defaults that people really didn't mind to just get rid of the debcomp stuff that comes up. Typically, you're supposed to avoid that stuff, but they didn't. Try and be deb-centric when you make applications. I was thinking on the plane. I actually added this. I have 300 plus applications. Aliasing in all of these, and I don't really have like a sane list on my website. And I was like, oh, how easy is that, right? I parse them out in Bash every day, but I never made a list for my website. If you want to look at them, you can crack open one of the packages and take a peek. If not, just wait a week or two, and I'll have a list up on the site. And I don't know. I thought of this one too. I was like, man, maybe some people install remastered CDs because they like the way it makes their operating system look. This would be kind of nice if someone wanted it, but obviously I would make it optional because that's not even something I would want. Obviously my references, sectools.org, where I got a lot of my packages, DEFCON in reference to the Get Off My Cloud speech, Debian.org for apt and deb manuals, same with Ubuntu, Fedora project for RPM, Backtrack Linux, where I got some of my stuff. And here's my contact information. The project, obviously, and my email address, which is also on the site. If you like it, if you use it, if you got some feedback for me, let me know. I'm looking for ways to make it better. This is mega early release for me. Everything is very stable for being an alpha release, actually. But I'd like to know what people think. So, that's it. Questions? Anyone? All right. Thanks for coming, guys.